Okay, you should have your power notes in front of you titled Solving Equations with Variables on Both Sides. And what we're going to do is take a look at our essential question, which is how do you solve equations that contain variables on both sides? Well, I'm going to give it to you in one really quick question here. Answer, I should say. Get the variables to the same side. That's what you need to do. If you get all the variables on one side, then it just doesn't matter. I'm going to talk to you about which side is better. It doesn't matter which side you go to. A lot of people always want to go to the left because they feel more comfortable over there. You're going to find I'm going to talk to you a little bit today why the left is not always the best choice. And I want to try to help you make it as easy as possible. So where it says answer, you should write this, get the variables to the same side. Okay, now we're going to review our steps. Okay, I remember how to do two-step equations, so let's kind of review a little bit. Okay, so remember, number one, we have to distribute if we have to. And again, you have these written on your other notes, so you can copy them from there if I'm going too fast. Second thing is you want to collect like terms. Now remember, this is where the more thing comes in now. Oops, when we're doing variables on both sides. So we're going to collect like terms. Before, we only collected on the same side. Now, we're going to collect on the side where there are more positive variables. And I'm going to show you how that works as we go along. So that's part B. Determine where there's more positive variables. If we always solve where there's more positive variables and always work towards the positive side, we won't have to deal with a negative variable and all these other crazy things that go on. So it's a lot easier if you work towards the positive variables. Okay? And then we're back to solving like a two-step equation, right? We solve with like a two-step equation. Let me get rid of this now. We're going to, it's going to let me, there we go. We're going to do the non-variable term first, right? We're going to add and subtract if we have to do that one. There's the constant and the coefficient of the variable. We're going to multiply and divide. And the last thing we always do is check our solution. So we want to kind of keep an eye on those things and what we're doing, okay? You'll notice on your paper we have room for some problems. We're just going to start solving some problems and see how this works. And I think once you kind of get the hang of it, you should be okay. So let's take a look at problem number one. So everybody write this down. 5x equals 8 plus x. Now when we're looking at it, there are 5 on the left and 1 on the right. 5 is bigger than 1, isn't it? So that means we're going to collect everything to this side because the 5 is bigger. So let's subtract an x from both sides. Because x minus x will go away, won't it? So that's what's going to make it cancel and go away. And that's what we always try to do, remember? Is to make it go away to get things alone. So 5x minus x, we're at 4x. Now this is nice and simple. Now this is a one-step equation. So we're going to divide both sides by 4. And now the 4's are going to cancel there. And we're left with x, and 8 divided by 4 is 2. And just like before, we have to check our solution. Now what's interesting about checking solutions with variables on both sides is that you're going to have to stick your answer into 2 places more than likely. So 5 times 2 equals 8 plus 2. So we got to do order of operations on both sides now. So we have 5 times 2, which is 10, and 8 plus 2, which is 10. So that works out. So we know that x equals 2 is our answer. So for those of you who've been cheating a little bit on your checks, you're not going to be able to do that anymore. You're actually going to have to do all the work because you're going to have to do it on both sides. Okay, let's go on to problem number 2, example number 2. I have 3a minus 4 equals 8a plus 1. 3a minus 4 equals 8a plus 1. So let's think about this a second. I'm going to draw my line. I have 3a on the left and 8a on the right. Which is larger, 3 or 8? Hopefully you're going to say 8. And the way I like to think of this, sometimes when people say, would you rather get $3 or $8? I think people would rather have $8, right? So that's the one we're going to keep. We're going to get rid of this one on this side. So because this is a positive 3a, right? There's no sign out here, it's positive. We're going to subtract 3a from both sides. Remember, that's what there's no sign there. That's how you know. That's positive, so the opposite is negative. We're going to use inverse operations. That makes the a's go away. Be careful, this is a negative 4, so bring that negative down with you. 8a minus 3a is 5a plus 1. We don't care which side the variable's on, because remember, both sides are equal. So it doesn't really matter what side it's on. So let's subtract 1 from both sides. I have a negative 4 and a negative 1 that gives me negative 5 equals 5a. And then I'm going to continue on. I'm going to divide both sides by 5. So I'm isolating my variable. Negative 5 divided by 5 is negative 1. Right? A negative divided by a positive is negative. And then we have that there also is the 1. 5 divided by 5 is 1. We're going to check our solution. So 3 times negative 1 minus 4 equals 8 times negative 1 plus 1. I'm going to draw a line because it's going to get crazy on this side too. So let's stay on the left side. 3 times negative 1 is negative 3. So negative 3 minus 4. And a negative 3 and a negative 4 is negative 7. Okay, let's check the other side. 8 times negative 1 is negative 8. And negative 8 plus 1 is negative 7. So it works out. So negative 1 is our answer. I'm hoping that people are feeling that this is pretty easy. It's not too tough. Okay. All right, we're going to do one more on this side before we flip it over. So let's get something a little bit crazier. 4w minus 4 plus 2w equals w plus 6. 4w minus 4 plus 2w equals w plus 6. I'm going to draw my line. Now remember, just like before, like our multi-step equations, remember I told you sometimes things have to go together, right? We have 3 terms on this side. So we got a 4w plus 2w. Let's put these two together before we see collect on the opposite sides. Let's collect on the same side first. So 4w plus 2w gives you 6w minus 4 equals w plus 6. Okay, we good with that? Then now we're going to take a look. I have 6w on one side and a single w on one side. Do I want to keep the 6 or the 1? The 6. Good. So I want to get rid of this 1w. So it's a positive w, so I'm going to put a negative w underneath it because the opposite is what gets rid of it, what makes it go away. So get rid of that, and I'm left with 6. 6w minus w is 5w minus 4. So I'm going to continue. I'm going to work on that constant. The opposite of negative 4 is positive 4, so I'm going to add 4 to both sides. That gives me 5w because the 4's go away, equals 6 plus 4 is 10. Again, we're going to get that w alone, so we got to divide both sides by 5 because the opposite of multiplying by 5 is dividing by 5. And we get w equals 10 divided by 5 is 2. So we've got to check it. And again, everywhere we see a w, we're going to put a 2 in. So 4 times 2 minus 4 plus 2 times 2 equals 2 plus 6. So again, I'm going to draw a line to keep my side straight. I'm going to do the right side first because 2 plus 6 is easy. What's 2 plus 6? 8. Good. All right, here we go. So we got some parentheses here. 4 times 2. 4 times 2 is 8. So I have 8 minus 4 plus 2 times 2 is 4. So again, we're going to work left to right. So 8 minus 4 is 4, and 4 plus 4 is 8. So we can see that it works out. So w equals 2 is our solution to that problem. Okay, we're going to go to the back side. We have 3 more to go. The last 2 are interesting. Let's do one more that's similar to this. I'll see if you guys can think about all the different things that we got to do. Let's get some distributing in there too. All right, so we got 3x. Oops, sorry about that. We have 3x plus 15 minus 9 equals 2 times x plus 2. 3x plus 15 minus 9 equals 2 times x plus 2. So remember, before we collect terms from side to side, we got to simplify what's going on both sides, right? So let's do that. On the left, the 3x is fine, but the 15 and the 9, we got to collect like terms. 15 minus 9 is 6. So let's rewrite this to be 3x plus 6. On the right side, we have some distributing to do. So let's give a 2 out to each thing. So 2 times x is 2x. 2 times 2 is 4. So we have 3x plus 6 equals 2x plus 4. So we're going to think again, where do we have more? Do we have more? We have 3x, we have 2x. Where are there more, 3 or 2? The 3. So this is the one we're going to get rid of. This is a positive 2x, so we're going to write negative 2x right underneath it because that's the inverse, remember? Inverse operations, the opposite. This makes that 2x go away. 3x minus 2x is just good old x plus 6 equals, that goes away, so that leaves us just 4. A nice one-step equation. We're going to subtract 6 from both sides, and we find that x equals a 4 and a negative 6 is a negative 2. Okay, we are going to check this solution. Again, this is going to get kind of hairy, so you want to go slow on your checks to make sure. So 3 times negative 2 plus 15 minus 9 equals 2 times negative 2 plus 2. Let's draw a line here. I'm going to work on the right first. So I have a 2 outside, and negative 2 plus 2 is 0. 2 times 0 is 0, so hopefully this left side works out to be 0. Let's see what happens. 3 times negative 2 is negative 6. So we're going to write down what's going on. And a negative 6 plus 15 is 9. And 9 minus 9 is 0. So it worked out. So our answer is x equals 2. All right, so like I said, we're on the back side of our notes, right? So you'll see examples 5 and 6. Normally at this time, I would have you watch another video from the textbook just to show you what those look like, but unfortunately I'm not able to record a recording. It doesn't come out very clear. So I'm going to do those problems for you. But if you go to your green card, this is Dr. Renfro. She's one of the people who does the videos. There are 2 different people who do videos. One is Dr. Renfro. So if you check out on the back of that, go sign on online and check it. You can see her do these problems as well. But I'm going to do these problems for you, the ones that she's talking about. And we're talking about 2 special situations. So we're going to go to example 5, right? And let's all write this down. 7x plus 4 equals negative 2x plus 4 plus 9x. Okay, 7x plus 4 equals negative 2x plus 4 plus 9x. And I'm going to draw my line down the middle there. Now 7x plus 4, that's going to stay the same, right? So 7x plus 4 equals. On the other side, though, we have some combining of like terms. I have a negative 2x and a 9x. If I put that together, I get 7x, and then I'm going to bring the 4 down. Maybe some of you recognize what's going on so far. Does the left side look like the right side? It does, doesn't it? So let's see if we can collect those variables and see what happens. Well, they both have 7s on both sides, so let's subtract 7x from both sides. What happens when we do that is all the variables go away, and all I'm left with is 4 on each side. Now, does 4 always equal 4? That's true, isn't it? 4 does always equal 4. 4 isn't 3, 4 isn't 8, 4 is 4. So because that's true, that means any number that I put in here is going to make this true. So our answer is special. We're going to write all real numbers. Okay, now I'm going to go over that again. If our variables go away and both sides end up being the exact same number, we're going to use the term all real numbers as our solution. That means it doesn't matter what number I stick in here, it's always going to work out to be the same. This is always going to be true. We can look right here in the black. I can put a 1 in there. 1 on both sides. 7 times 1 is 7. 7 plus 4 is 11. 11 equals 11. Doesn't matter what number I put in there. It's going to happen. So you're going to be on the lookout for a couple of these in your work this week. So anytime where it gets to be this all by itself, this is what we call the proof. What I'm highlighting right here, 4 equals 4, that's your proof. You have to show me proof. You just can't look at it and just say, hey, it's all real numbers. Okay, you've got to show me proof. So I expect to see both of those things, proof and the statement. Okay, and let's do one other one. Again, this is special. So this would be example 6. Let's write down 5x equals 9 minus 10 plus 5x. Okay. Now, we got a couple things going on, don't we? We got 9 minus 10. So let's fix that. So 5x equals 9 minus 10 is negative 1 plus 5x. Now the sides don't look the same, but they both have what? They both have a 5x. So again, if I subtract 5x from both sides, that goes away, doesn't it? On the right, I get negative 1. 5x minus 5x, well, that's 0. Does 0 equal negative 1? That's not true. That's false. That never is going to happen. 0 is never, ever, ever going to equal negative 1. That's a false statement. So whenever that happens, we're going to write down no solution. Okay? No solution. So once again, let me get over here and grab this pen, highlighter. If we get our proof shows us that both sides are not equal, okay, we're going to write the words no solution. So those are our specials, and those are the ones you have to think about. Now another way, just so you know, another way to write no solution, and you might see this in the book, it'll be a circle that looks like a 0 and a line through it. That's the not symbol. That's the other thing you can use if you wanted to write no solution. You could use that if you wanted to. Okay? But remember, again, you can't just write no solution with the not symbol. You have to give me proof to show me why you're choosing that.